Good morning, InnoVEX 2023, and good morning, Taipei. Ladies and gentlemen, welcome to Asia's Smart Mobility Ecosystem Forum. As vehicles today grow to become more electric and smarter, automotive semiconductors and electronics will have a stronger presence in modern transportation. This growing value shows how important the trend of being smart and EVs are. These trends are represented by the growing markets of automated driving, smart cabin, and other applications. To address this trend, InnoVEX 2023 invited speakers representing ARTC, SUBARU, Renesas, and ALPS ALPINE. The speakers will share the insights on the latest industry trends and the topics on Taiwan's automotive electronic industry, ADAS, automotive semiconductors, and smart cockpits. First, let us welcome Chairman Frank Huang of Tata, who will deliver the opening speech. Let's welcome Chairman Huang.
各位来宾，各位在座的朋友，大家好。我们今天特别欢迎我们今天特别欢迎台护良协会理事长王启国博士 ，SUBARU Senior General Manager Mr. Shibata, ALPS ALPINE Vice President Mr. Watanabe, and the Renesas Senior Vice President Mr. Kataoka. 感各位有这么多的远道而来的这个朋友哦，来参加我们这个 forum， 可见是汽车电子呢它的重要性哦非常明确啊。根据那个 Semi 他们的 projection 到2028年，by 2028, the world's electro product for automotive will reach to $400 billion. It's very, very big number, okay? 以前呢，我们一个车子大概$500-600 per unit per car on the electronics, but now gradually to EV, the total amount of electronics somewhere between the 2,000 to 5,000. So we see this progressive, especially in the automotive drive, cockpit, and many automatic electronics utilization, and most advanced automotive company have their car become AI, and they almost you can see a car maybe have a 2 or 3 equal computer system in running their car. Especially in the past 3 years in China, the EV has reached to tremendous amount. They're probably worldwide demand on EV probably reached 7 million pieces. Among them, Chinese has exceed 5 million. Okay, so actually, in the entire EV, China has the biggest market ever. Okay, and use a lot of electronics component. And also, the United States, right now, the American major company, Ford, GM, and any other automotive manufacturer, now try to move everything into EV. One of the major reason is the successful of the develop new electronic application for automotive. Okay, the other is entirely electronic, like a car, use a battery, and in China the they developed the electric car company with the, charge bar, and they install many charge bar. In here, our American has not so many electro bar which used to charge the car, but getting bigger and bigger amount. And of course, in summary, I think the electronic company and semiconductor company has used trying to develop more chip for automotive use. So I think combine automotive and electronics and the computer all together will become a very, very big industry complex. I think it will match our TI industry, okay? And especially recently, the AI become a major focusing for next generation electronics. So I think automotive also will be joining the AI. And so for AI, internet, automotive driving, EV, everything will be integrated together, okay? And also in order to reduce the carbon dioxide, we may have to use more electronics so that because when you use car, 当你用汽车目前的汽车，你主要还是 gasoline。可是你用的电子汽车的话，它只要充电，那电哪里来 ？battery 那个 battery 的电来源可能多元化，从各种不同的电，所以这个呢，对于 reduce carbon dioxide 空气中的那个污染会降很多。到2023年呢，到2030年 by 2030, I guess only small fraction of the car is using gasoline, and this is biggest change ever since the day of automotive, and now it's going to change. And I hope our association combine the automotive and electronic together can really join become a component supplier for EV or other electronic car, which I think our member can enjoy a prospect of the growing business. This is annual everybody forum. I hope that each year when we talk about this and everybody the business is progressive and booming. I wish everybody have a good business and health. Thank you very much.
Thank you, Chairman Huang. Please kindly stay on the stage. Chairman Huang, kindly stay on the stage. We're going to take a group photo. All right, thank you so much. We would also like to invite all the speakers today to join stage for a group photo taking. First, let us welcome Mr. Yoshikatsu Watanabe, the Vice President, Infotainment and Sound Business, Alpine brand, ALPS ALPINE. Welcome. Also, Mr. Eiji Shibata, the Senior GM of Engineering Development, GM of ADAS Development Department, and Chief of SUBARU Lab, SUBARU Corp. Welcome. Let us also welcome Mr. Jerry Wang, the Chairman and President of Automotive Research and Testing Center. Also, I would like to invite Chairman Meng Feng Wu, the Cross-Industry Collaboration from SIG, as well as Chairman Alex Wang from Automotive Semiconductor, SIG. Also, Chairman James Chen, the Smart Cockpit and Intelligent Drivings from SIG. As well as Chairman Franco Lai, the Power Energy Control from SIG. Last but not least, let us welcome Ms. Sakura Yang from TCA onto the stage for a group photo taking. All right, all our guests, can we kindly move closer to each other and look into our camera in the middle. Let's show your best smile. 3, 2, 1. That's incredible. Shall we also do a thumbs up? Okay, show your best thumb and the best smile. Okay, 3, 2, 1. Go for Asia Smart Mobility. Okay, I think we have some of the camera on the right-hand side. Can you shift a little bit onto the right to take another more photo? All right, show the thumbs as well. Can you put up the thumbs? Okay, no, bad smile. Okay, 3, 2, 1. Asia Smart Mobility, go, go, go. All right, thank you all our guests onto the stage. Thank you, thank you. And then our guests kindly return to your seats with extra care. And all our speakers, thank you once again for joining us. Please return to your seat first. And we will now have the first speaker of the day really soon. Okay, let's welcome our first speaker, Mr. Jerry Wang, who is also our guest on stage just now. Onto the stage once again, the chairman of the Automotive Research and Testing Center, ARTC, to share his insights on opportunities provided by Taiwan's EV and automotive electronics industry. Mr. Wang, please.
Good morning, ladies and gentlemen. I'm Jerry Wang from Taiwan Automotive Research Center. Before the expert from Japanese, I want to introduce about our automotive industry and some about government policy. Okay, in this year, our automotive industry has focused on 4 key fields in the connectivity and the autonomous and the sharing and the electrification. There are more and more new technology put in the car, like ADAS system, and ADAS is for driver assistance. And we have like a V2X, and we have the car sharing by the connect to the internet. So the car are not only for transportation, car like smart mobility. So there are more and more ICT application put in the car. Like the cell phone not only for communication, cell phone can do many things. So in the future, the car also can do many ICT applications. In this 100 years, our automotive industry have 120 years experience. There are many big changes. At the beginning of the 21st century, we have the DVD player and the GPS navigation emerge in our car. In 2010, we have ADAS system and the camera radar to give assistance to our driver. Now we have the high voltage and the electric motor and the V2X. So they are very big change. The business opportunity is endless. Now let me introduce some data about our industry. The global sale of the EV is from just 2 million to 10 million units in these 5 years. The major driver is from the rise of Tesla and the global government to push the carbon net zero policy. So the EV marketing, we think is no sign of slowing down. On the other hand, on the right side is for our automotive in electronic industry. The industry value is from $295 billion in 2022, and expected to reach 400 billion before the 2027. So this the main driver is by the autonomous technology and the computing power of AI put in the car. So some people ask me why the car have a big change. The main reason is the AI, is a controller, many controller, over 200, 300 controller, and the process chip put in the car. About the Taiwan is similar. Taiwan automotive electronic value is increased very quickly. In 2022, there are about 12 billion US dollar. We are expected we will double this value to 21 billion only in 3 years. So after three years, our automotive electronic value will increase very quickly. The major product is about the driver information system. But maybe we need to modify this word. We will change it to smart cockpit. Smart cockpit will control more different products. Besides the small cockpit, we also have like a electric transmission system, like electric motor, controller, and the inverter, and some in the body control and the security system. Taiwan ICT industry also is not top-notch in the global. We know our PC and notebook manufacturer is controlled over 80% of global market share. And in the semiconductor manufacturer, like TSMC and the UMC, we have the 62% market share. Besides it, we have very good smartphone and the IC design and some electric product manufacturer. Let me introduce some of our ICT group. All these groups have been going to the global car maker supply chain. For example, the Delta Electronic, they produce the charging station and the powertrain system support to the main car maker. And the AUO and the Interlock is our leading consumer panel manufacturer. Now they to focus on the smart cockpit solution. And the Pegatron group also to produce many special products. Now they also to issue the smart cockpit solution. And the UMC Light-On group, there are many new products. And the Foxconn is a leading OEM company to do the Apple iPhone. Now they design and produce the whole vehicle, whole EV and the e-buses for the international client. So all this ICT industry to join together to set up a TADA. TADA is the Taiwan Advanced Automotive Technology Development Association. They were to integrate all the resources from government, industry, and the university to working together to set up a new generation automotive product. So our chairman just gave an open speech. So finally, because we know that Japanese have a very best car brand and the best tier 1 supply chain, and we believe Taiwan have very good ICT industry, and we can provide the integrated service, and we have the rapid response to market change, and we have the good intellectual property protection. So we think we are very reliable and dependable for Japanese automotive industry and the global automotive industry. And thank you very much. This is my introduction before this seminar. Thank you.
Thank you so much, Chairman Wang, for the overview of Taiwan's EV and automotive electronic industry. Please kindly return to your seats with care. Thank you once again. All right, with the development of the automotive industry, smart cabin will become more and more important to provide a better experience for the users. Let us now welcome Mr. Yoshikatsu Watanabe, the Vice President, Infotainment and Sound Business, Alpine brand, who has shared about ALPS ALPINE digital cabin solution with us. Please.
大家好，大家好，
Oh,
我是ALPS ALPINE路边好胜。今天很高兴 参加 Computex Taipei，非常感谢。Hello everyone, I'm Watanabe from ALPS ALPINE. Today, I'd like to explain about our digital cabin solution. Before that, let me introduce myself. Again, my name is Yoshikatsu Watanabe. I'm a little bit nervous now since this is the first time to have this kind of speech in front of a large audience. I hope to share what we are thinking through my very good English. And if you have any questions later, please ask slowly with very easy English. Regarding myself, I joined Alpine in 1986 and have worked for Alpine brand product development for a long time. In 2012, I moved to China and I was responsible for R&D center in Dalian. At that time, I visited Taiwan several times and communicated with Taiwanese companies. After that, I returned to Japan. I was responsible for engineering division, and I have been working in this company. After that, I returned to Japan. I was responsible for the engineering division. Since 2019, I have been working in the current position as ALPS ALPINE Vice President. I'm responsible for Infotainment and sound business, as well as Alpine brand business. Something interesting about me, I love playing baseball, the banchu, and golf. I wish to play in Taiwan in the near future. At this point, let me explain starting from ALPS ALPINE corporate introduction. Environment change for our company and digital cabin solution. First, regarding corporate introduction. ALPS ALPINE was established in 1948, Kataoka Electronics. Later, it became ALPS Electronics. In 2019, ALPS Electronics and Alpine integrated in one company as ALPS ALPINE. The company is now 75 years old. And now, sales is 935 billion yen, and the number of employees are around 30,000. If you look at the business segment, more than half of sales are automotive module and system. And components are including automotive devices, so that total ratio of automotive sales is roughly 70% of the total company. Let me share more about our company history. It was founded in 1948 as a joint venture between ALPS and Motorola was established. And 8-track portable player was launched in the US. The joint venture was cancelled, and later it became Alpine. At that time, mainly high-end audio radio tuner, cassette player are produced. In 1981, we developed the world's first navigation system with another automotive manufacturer. Also, around 2010, we developed the industry's first large-screen aftermarket navigation system called Big X. Our activities are always challenging the new value in cabin experience. And recently, the need to integrate other systems into the cockpit has expanded. And ALPS Electronics is also expanding products related to in-cabin, such as switch modules for steering, door panels, or air conditioner. So we co-developed the premium cockpit system in 2018. And finally, ALPS and Alpine were integrated into one company as ALPS Alpine in 2019. And nowadays, we produce a lot of HMI, human-machine interface devices, such as various switches, touch panels, haptic commanders, and also lots of sensors, such as magnetic sensors, current sensor, environmental sensors, and so on. And connectivity devices, such as Bluetooth, Wi-Fi, GNSS, V2X, and 5G module for automotive as well. On the other hand, we are producing various products and systems by utilizing those devices, such as sound system, display, infotainment system for global automotive manufacturers. And as Alpine brand, we continue to produce those products, but also we launched Alpine style retail store in Japan in order to do direct marketing to end consumer by providing not only in-cabin products, but also total car life solution as motto. And now, the Alpine style, we opened in 6 locations in Japan: Fukuoka, Yokohama, Osaka, Nagoya, Saitama, Onahama. And we started to produce customized car, including exterior and interior customization. In this year, we launched 2 new original cars, Carica and Havana. By utilizing those devices, modules, products, and Alpine brand business, we challenge to create new value through digital cabin solution concepts for upcoming mobility and mobility life. I will explain about digital cabin solution later in detail. Next. Let me briefly share about environmental changes for our company. We are facing significant changes in our business circumstances. The SDGs are one. Any business in the world is now requested to take part in the global fight against climate change and also required to create innovative solutions for society. COVID-19 has accelerated the diversification of life and work styles, consumer value, and the definition of happiness. Under such circumstances, we need to break through our old business model. The automotive industry has seen new activities beyond the area of expertise. For instance, carbon neutrality is no longer a concern of the auto industry alone, but it should be the area of interest for all industries. The case trend will cause a change in value added for cars and a shift from hardware to software. More and more ECUs will be integrated, making custom hardware disappear one by one. We need to make better use of the latest technologies to respond to all ongoing and upcoming changes. The mobility sector will keep evolving with the advancement of cloud and data transfer technologies. The metaverse and other virtual technologies will enable people to do more things while staying in one place, causing a paradigm shift in the way people think about moving to other places. Fewer necessities to move to other places will transform the process into something more special than it is. As a business in the mobility industry, we are expected to create new products and services that will further enrich the getting more and more special experience by moving to other places based on those external factors. Let me finally about our direction, digital cabin solution. ALPS ALPINE is aiming to be an innovative T-shaped company. This is based on our strengths that we are developing both hardware and software, from device to system products, and from consumer electronics to automotive business. So, we can utilize elemental technologies of ALPS solution and software and system integration of Alpine solution to provide new value for the changing automotive industry, as well as for other industries. For the automotive business direction, at present, we handle almost all automotive HMIs, including displays, audio equipments, shifters, control panels, for center console, door, and armrest, and so on. Throughout 2027, we are going to integrate all the HMIs into a group of products as an internally linked cockpit. Then, toward 2030, we are going to apply the integration process to the entire cabin space, turning it into a living room on wheels. These plans will require us to evolve the existing control into a unique system by utilizing various sensors acting as an interface between cars and people. A bit more talking about concrete products. Current lineup is individual functional products mainly. We integrate toward cockpit by domain controller to handle not only conventional infotainment, but also meter and head-up display, as well as sound system, including audio signal processing. Furthermore, toward digital cabin. We integrate more various inputs like sensors and various outputs like actuators in order to realize a rich experience in the future mobility cabin space. System configuration is depending on the automotive manufacturers, but macro trend is of course to integrate not only IVI meter, but also body domain and ADAS domain and zonal architecture will be coming soon. Based on those architecture changes, we are adapting to provide cabin controller and necessary peripherals and middleware to realize in-cabin experience. Especially various sensors and actuators with middleware, we believe are one of the unique technology from ALPS ALPINE. To adapt the architecture changes, we also strengthen alliance. We already announced Capital Business Alliance with Nippon Seiki, who has strength around the meter and head-up display area. Also, for Development Business Alliance with TS Tech, who has strength around the seat and trim area. We are co-developing with automotive manufacturers for the future cabin system. One example. Let me explain which is developed with TS Tech last year. We call XR cabin POC. This is including actual sheet and steering and door trim as hardware. But the HMI interaction is realized by virtual reality, so that we can experience quickly the various use cases such as ADAS warning, immersive entertainment, relaxation space, and verify the value, and then make improvements if necessary. We believe future mobility, especially battery EV with automated driving, will require us to provide a rich experience in the cabin, not only while driving, but also while stationary condition as a third room of the home, so we can fully utilize this POC for a new value creation. To realize the value, on the other hand, powerful processing capability is necessary. We made partnership with Qualcomm to work together to bring advanced automotive in-cabin capabilities. Actually, we produce integrated ECU we call HPRA, stands for High Performance Reference Architecture, by implementing Qualcomm's Snapdragon cockpit platform. Through this reference, we are now developing domain controller for EU and Japan customers. Digital cabin solution requires such integrated ECU as well as various peripherals, including sensors and various outputs such as integrated display, zone sound system, and actuator in the seat, and so on. We are continuously making alliance with other than introduced companies. In conclusion, as a summary, first, environmental change, especially social requirements like SDGs, we need to respond to solve with latest technology. Especially in automotive industry, we believe battery EV with automated driving will impact cabin space importance. Second, our direction is to utilize ALPS ALPINE strengths, which is a T-shaped company, to provide digital cabin solution. Third, in order to realize this, we all need collaboration. ALPS ALPINE innovates value through digital cabin solution concept for changing automotive industry. To do this, collaboration is necessary. How do you think you can help improving our business? I truly wish to work together with all potential partners here in Taiwan. Thank you very much. 谢谢大家。
Thank you, Mr. Watanabe, for sharing on ALPS ALPINE's technology and digital cabin solution. Thank you. Kindly return to your seats. Thank you so much. Up next, we would like to welcome Mr. Takeshi Kataoka, Senior Vice President and Co-General Manager of the High Performance Computing from Renesas. Let us welcome him. Please.
Okay, thank you very much. So, good morning, everyone. Actually, I'm Takeshi Kataoka, Senior Vice President of Renesas Technology. So, first of all, thank you for very much about inviting this forum. So, I really appreciate always Taiwanese friends warm welcome. So, thank you very much. So today, I'd like to explain about automotive industry trend, actually from semiconductor supplier perspective. So let's go next. Okay. At first, I'd like to show our, company's very brief introduction
This is Renesas.
video. Please see.
Renesas was born after three Japanese technology giants, Hitachi, Mitsubishi Electric, and NEC, took the bold step of merging their semiconductor businesses to create one company. It is from this rich technological heritage derived from these companies that the foundation of Renesas is formed. Our proven technology and unwavering commitment to quality are what set us apart from our peers as a world-leading semiconductor company. More recently, Renesas began expanding its footprint in Silicon Valley, first with the acquisition of Intercell in 2017, and then IDT in 2019. Renesas successfully combined its proven quality with top-class safety standards and technical competency with the innovative products and entrepreneurial spirit of Intercell and IDT. In 2021, Renesas completes its acquisition of Dialog, expanding its footprint in Europe. With Intercell, IDT, and Dialog now in the fold, Renesas enters a new era as a truly cosmopolitan company with a progressive mindset and a modern vision to lead the industry. What is Renesas's purpose in business? Our purpose is simple: to make our lives easier. We do this by harnessing the power of technology to complement human capabilities. And our lives don't just mean the people who use the final products that are powered by our technology. It means the lives of our suppliers, customers, our employees, and their families. To make human lives easier, our products provide advanced driver assistance systems, alternative fuel vehicles, robotics and human-machine interaction for smart factories, state-of-the-art medical devices, home appliances with intelligence, data centers handling big data and data explosion, fast and low latency 5G wireless communication networks. To make our customers' lives easier, we deliver a vast array of semiconductor products such as MCUs or SoCs, analog and power to provide complete coverage for the broad signal chain in electronic systems. Renesas customers win by tapping our rich portfolio of analog power and embedded processing solutions. Our winning combinations help customers accelerate their designs and get to market faster with high performance and high quality products. The winning combinations address the needs of new and expanded customers and continue to power our customers' systems with compelling products and solutions designed with our proven technology. Renesas has weathered many storms and changes and is in a constant state of transformation to become a stronger organization. We will continue this journey to make a better world through our technology and make a positive impact on the way we live and work. Here at Renesas, everyone can make a difference. Together, we can make change happen.
Okay, so then next, please. Yes. So, as the video mentioned, actually, Renesas is originally Japanese three company, Hitachi, Mitsubishi, NEC. And then we are strong about digital product, MCU, SoC. But after, acquiring many analog company, IDT, Intercell, Dialog, so we are, expanding our product portfolio, not only just digital, but also analog and the power. So now we are offering, very wide variety of product for solution for automotive, industrial, infrastructure, and IoT for various applications. So today, I'd like to focus on automotive. So next. So this is the agenda. So at first, I'd like to explain about the mega trend in automotive. And then I will explain three key things for this mega trend change. One is the evolution inside the vehicle. This means the E-architecture change. And the second is the electric vehicle, of course, EV. And third is the ADAS. Then I will summarize. Okay. So this is a mega trend in the automotive industry. So, actually, Watanabe-san also mentioned, now automotive industry is in a very big change in 100 years, So value of cars clearly changed. So now, especially, this case means a connected, autonomous, shared electric. This is a key key component, key thing, key items for this big change, especially autonomous means ADAS, also electrified xEV. These, two area application is growing very rapidly together with e-architecture change. So, okay. So, for example, this is a big change from gasoline car to xEV. So, this shift, caused a significant change in the requirement for a component level. For example, number of components is significantly reduced from gasoline to xEV. Also, power system control-wise, clearly change from conventional engine control to a motor control. Then, energy source also change from gasoline to battery. This means that, battery management is a key thing for, very good, power management. Also, no more transmission, actually. And then vehicle structure also will be simplified in xEV. That means that many new applications is now coming for xEV. Okay. So this kind of very big change wise, actually value of car is clearly changed from conventional mechanical thing to more software and services. So now OEM and Tier 1 is very much focusing on to make their own software platform and also architecture, because value of car is now changing to such software and services. Then especially OEM tries to define both hardware and software architecture to be optimized for such software platform. So because they think this will be a value. So for example, as you know, Tesla is making their own SoC, right? To optimize their solutions. So in such sense, actually OEM try to directly connect it with semiconductor supplier and also for example foundry and so such kind of direct communication is now happening. Okay. So from here I'd like to explain three key things for this big change. So first is the evolution inside vehicle, means the e-architecture change. Okay. So as you can see, left side, this is a conventional old automotive architecture, distributed architecture, which means each ECU connected, very complex manner. So, but due to a system, will be complex. Also, number of ECU will increase. Then now it's very difficult to make software and the system for this kind of complex architecture. So that's the reason why now OEM and Tier 1 is shifting to a more centralized architecture, which has a central gateway and also domain control. Central gateway is operating data communication, and also each domain control is operating each domain. Domain means application. For example, powertrain domain and chassis domain, also body domain. So this centralized architecture, actually this is called the domain architecture, will enable OTA software update, also scalable software development, also wire harness reduction. But more advanced architecture-wise, now especially emerging OEM like Tesla and BYD, also other some OEMs try to move more simplified architecture, named zone architecture. So this zone architecture is composed by a central gateway plus each zone ECU. So zone means a location. So each zone ECU is operating application for such locations. So this will enable further OTA software upgrade, also further reduction of wire harness. Okay. So this kind of e-architecture evolution will simplify and optimize to achieve software-defined car, which OEM is now very much focusing. So, but to realize this zone type of architecture, actually zone ECU must be more flexible for software usability and software portability, because depends on the car model, OEM think, they want to reduce their software asset, across car model or across, car generations. So they want to reduce, same software between a zone or between a gateway and zone. So this is a very fundamental thing. Okay. So for such high software reusability and portability, this is a key thing for zone, architecture. But because this will be the first time to market, also lower development cost for OEM and tier ones. So Renesas is offering a full scalable solution with the software IP commonality to realize this software reusability and portability. I will explain later about this. Okay. And also, Renesas is offering, a total solution for various automotive application from high-end to low-end. As you can see, for high-end, high-performance computing for ADAS, gateway, infotainment, and then domain and zone control, also conventional control, vehicle control, by using our, MCU, and also actuate and sensor thing to manipulate, a motor and such kind of thing by using our 16-bit micro for actuator and sensors. So, okay. So now let me show our central gateway solution. So please.
In a world switched on, Automotive Ethernet will become a game changer for the next generation of vehicles and mobility. While CAN has dominated the car network for nearly decades, we face a revolution for the in-vehicle architecture when moving to Ethernet-based networks. Exponential growth in bandwidth combined with the quality of service allows innovative new architectures to improve comfort and safety in order to pave the way to a highly assisted and finally the fully autonomous car.
With our partner CTTech, we have developed this evaluation platform called Vehicle Computer 2. It represents a multi-gateway solution that supports all major automotive communication interfaces covering LIN, CAN, FlexRay, MOST and Automotive Ethernet and allows flexible routing between all of them. The box is equipped with the powerful Renesas RKH3 SoC, the RH850 F1K microprocessor and an FPGA-based implementation of an Ethernet TSN switch. With these components, the box provides the most common automotive interfaces in a robust housing. The box can be used by OEMs, Tier 1s for evaluation, prototyping or data logging and expands the existing toolkits with automotive-specific requirements. Due to the variety of interfaces, many use cases are possible. Central gateway, zone ECU, or central computer are just a few examples.
In order to demonstrate this technology and to showcase the features of deterministic Ethernet, we developed a demo based on the VC2 in an in-vehicle network with a zone-based architecture. The demo consists of 5 gateway ECUs that are connected by Automotive Ethernet and CAN-FD in different network structures such as ring, star or mesh. A centerpiece of the demo is the ability to operate the IEEE 802.1cb standard for frame replication and elimination for redundant communication. These simple RC-type model cars have been equipped with front cameras that send the live stream from the driving track to the front zone ECUs using wireless technology. These ECUs forward the video to the central ECU for track detection, path planning and driving control. The steering and driving commands are then sent by the rear zone ECUs to the RC control of the model cars. With disabled frame replication mode, any failure on a link will immediately stop the car in operation. Now, after enabling frame replication, the cars move on because the existing links between the boxes will use both directions. Mesh mode offers more redundant links between the boxes. Such configuration tolerates more link failures. Finally, a mixed network with CAN-FD and Ethernet also covers network diversification, which is an important element for functional safety. The backup for control traffic is covered by CAN-FD. So even with failures on both Ethernet links, the actuation control is still in operation. Thank you very much for your attention. I hope to see you soon on a live event from Renesas.
Thank you, Ube. Okay. So, okay. Yeah, next. So again, to realize such kind of zone architecture, Renesas is offering full scalable lineup from low end to high end. As you can see, 16-bit micro, 32-bit micro, also high performance SoC for various applications. Then customer can enjoy their software asset reusability. As you can see on right side, this is somehow approximately reusable ratio, roughly 70 to 80% across car model and across applications and across generations. Okay. And also one more very important thing to realize, software-defined car is a shift left based on a digital twin. This means the digital twin means physical world and virtual world. So our customer really want to focus on system level requirement definition, also software development, apart from real hardware, real silicon. So Renesas is offering software virtual software development environment like simulator and emulator model, right? So customer can enjoy by using such kind of development environment in cloud based before real silicon come. Okay, so this will be a very big benefit for both our customer and also Renesas. So for customer side, clearly they can start their development, also evaluation before real silicon come. Means that they can reduce development time. This is good for time to market. So for Renesas, good thing is we can get feedback from our customer about our product specification, definition, and architecture before real silicon come. Which means by getting such feedback, we can modify or change our architecture of product, even definition, specification. So this will lead our product very competitive. Also to avoid any rework after real silicon come. So these big changes are happening in semiconductor world with our customers. Okay. So next is XEV. Sure. So yes, XEV market is very much expanding. So there are several key applications as an inverter for motor control, onboard charger for battery charging, and DC-DC. This is for power management, also battery management system for battery management. So Renesas is offering our product for all these applications via power product via SiC and IGBT, also analog product via PMIC, power management IC, also BMIC, battery management IC, also sensor and also gate driver for power power semiconductor. Also with our strong MCU for control these XEV applications. So let me see our inverter solutions, please.
Renesas Electronics XEV Inverter Reference Solution. This reference design from Renesas Electronics offers the world's smallest 100 kilowatts class inverter to address the rapidly growing market for electric and hybrid electric vehicles. The hardware design is complemented by a calibration tool to maximize the performance of the motor and motor control software to optimize the performance of the host microcontroller. The hardware design includes the Renesas RH850C1MA2 microcontroller, optimized for motor control with a built-in resolver to digital converter, power management IC designed specifically for RH850, high voltage gate driver with built-in micro-isolator technology, and the IGBT and FRD power stage devices. Using this 100 kilowatts class motor bench, Renesas can accurately measure motor parameters and evaluate system performance using the incorporated hardware and software. Renesas is also readily available to help customers realize new requirements at the system level. Renesas has built up a demonstration vehicle equipped with this inverter and confirmed its performance in actual driving environments. Customers can utilize this solution to easily realize a highly efficient system and immediately evaluate a prototype inverter system in an actual vehicle. Prototype development that typically takes 2 to 3 years can realistically be cut in half.
Yes. So Renesas is offering, total solution, digital product, MCU, SoC, analog, and power with software. Even with, software developed environment, as you can see. So actually, now XEV market is, changing to more downside. Downside means that, each application of XEV means that inverter and onboard charger and DC and the battery management system will be consolidated to one ECU. For reducing cost and also space, also wire harness, right? So Renesas can offer total solution by using our product, especially our MCU is very powerful. So our MCU can handle all application by one MCU. So this is our solution. So customer can enjoy system level optimization by using our turnkey solution. Also, this will accelerate customers' development. Okay. And yes. And one more important thing about XEV is the power semiconductor itself. So as you know, now IGBT but shifting to SiC for inverter control. So maybe both will be used anyway due to some reason, cost reason and or supply reason. But actually, Renesas also, will offer, both IGBT and SiC. So as you can see, left side, our IGBT wise, as you can see, total loss is, better actually, compared with our competitor. This is, very much, benefit for our customer OEM for longer distance driving with, longer battery consumption time. So this is a key characteristic for this IGBT for XEV. And then we already decided to expand our internal capacity in Kofu. K6 is a Kofu in Japan to expand our production for IGBT, 12-inch IGBT. And then right side, this is a SiC. So yeah, we also decided to invest for our internal fab for mass production for SiC. So our SiC characteristic actually switching loss is also best in class performance for EV inverter. Also we already did completed automotive qualified. So Renesas will continue to offer both IGBT and also SiCs. Okay. So last portion is AD, ADAS. Okay. So about AD, ADAS, actually there are several key applications. So sensing-wise, yes, of course, camera, LiDAR, radar, these three, sensing is very important. Then, from these, data from such sensing, computing, high-performance computing is very important by using central AD, ADAS, SoC. Also gateway for data handling, also domain and zone control. Then actuator side, 60-bit micro will handle real driving and braking and steering. So Renesas can offer total solution for these all applications by our SoC, MCU, also analog devices. Okay. So this time, let us see our autonomous driving solution demo, please.
So what we're going to do is take this car for a test drive on a track in the autonomous driving mode, so you can see some of these areas of autonomous driving that we're studying. So if I use the HMI here to enable the system and press the automated drive button, we start moving. And right now, the vehicle is able to follow a path onto the outer loop of our track, which is defined by a high-definition map. Here you can see a vehicle that is coming. Our car has detected that vehicle. We wait for it to pass, and then we can proceed. So we're also able to use our cameras to detect traffic signs. For instance, this 20-mile-per-hour sign, we've detected that. You can see that on our display, and so the vehicle is going to hold that speed. You'll see that we're detecting many signs throughout the track, including this construction sign. And you'll notice that once we've detected that sign, a cue comes up on the HMI asking us if we would like to check for an over-the-air update of our high-definition map. A lot of times a construction sign could be, could signal to our system that maybe the environment has changed and we might want a new map. So if we go ahead and accept the update, what we've just done is triggered an over-the-air update, and this is done with a secure mechanism that we created in cooperation with our partner, Ubiquiti, in order to bring that high-definition map into our system through a completely secure channel. Continue around the outer loop. What we'll notice is that the vehicle is able to maintain position perfectly in between these lane markings. These lane markings are actually very important to us. We can use these as visual cues in order to determine where the vehicle is on our high-definition map. So thus far, we've been staying on the outer loop. Now I'd like to go into the intersection portion of our track. And the way we tell the car to go in the intersection is by using the turn signal. Now, as we turn into the intersection, what we'll find is that with this intersection, we have 4 traffic lights. And each of those lights we detect with this car with a combination of both V2X and the cameras on our roof. The cameras can actually look at the light and tell if we're green, yellow, or red. We wait at the red light, and we want to go left, which we tell the vehicle by using the turn signal. But of course, we've also detected a vehicle that we have to wait to pass us. And once the vehicle's passed, we can make our left turn. Of course, the vehicle detected with both cameras, V2X and LiDAR. We come to a stop sign that we've also detected with the cameras on our roof. And now, with a clear path, we can go ahead and turn back onto the outer loop. So now we're going to go ahead and turn back into our intersection, which we use with the turn signal. Only we're going to make things more interesting. We're actually going to fail, using our HMI, one of our vision processors, right? What you'll notice is that we still have full functionality. Our vehicle will still turn in the intersection, only now our car, having noticed that we have a failure, is looking for a place to park. But as you notice, all of our parking spots are full of cones, pedestrians, things that just make the parking spot not empty, and therefore, despite the fact that we detected it, we can't park there. So it takes very advanced computer vision to tell that you have a parking space, but you can't park there because there's some object in the space. We still have enough functionality in this field mode to wait for our red light to turn green. Now that our light has turned green, we will go ahead and proceed. And here we actually have an empty space. The vehicle detects that it's empty, and we go into a parallel park to pull over into our fail operational location. So this entire time, we've found that we've either been in our drive route mode. Now I'd like to enter the third autonomous driving mode we have in our system right now. We call that drive parking. And when I press this button now, our system immediately is looking for our home parking space. And so what it'll do is it'll continue driving the outer loop. And then when we get to the end here, we're actually going to make a left in the car automatically because it knows that our home parking area is right here. And as we pull in, immediately it's looking for an empty spot, that there's a parking space candidate based on the lane marks, and it goes ahead and pulls us into our home parking space. And that concludes the demonstration.
Thank you, John. So, okay. Okay, go back. Yes. So this is Renesas offering for, especially for high performance SoC. So we are offering very wide variety of SoC from low end to high end for high end application, autonomous driving, and also ADAS and gateway, cockpit, IVR, and cluster by various products. Okay. Then, so one more important thing of ADAS evolution. So now currently basically ADAS function is level 2 or level 2 plus, but in the future such kind of level will evolve to a level 3, maybe level 4. I'm not sure, but so for such evolution, number of camera and radar will significantly increase. Also, important thing is fusion operation. By using both camera and radar data, it will be a key thing to realize more precise image and object detection. Okay, so up to now, actually, Renesas is focusing more central radar and camera by using our best-in-class SoC for camera with very low power consumption. But by acquiring radar company, actually named Stradian in India, actually we are now expanding our solution space to more adding radar actually. So our radar MMIC is best-in-class with advanced 20 nanometer RF CMOS, actually fabricated in Taiwan. So anyway, so then also this our SoC can handle both camera and radar data in a fusion manner by using state-of-the-art AI operations. So this will enable OEM to make more precise image and object detection for ADAS. Okay. So then summary. So again, automotive industry is in a very big change in 100 years. So Renesas is offering very wide variety product, as you can see, to support OEMs and Tier 1 to make their own platform, software platform architecture. But of course, Renesas cannot do everything by ourselves. So Renesas is, working, collaborating together with our partners, means, foundry, OSAT, raw material suppliers, EMS, and ODM, and IDH, right? So, yeah, and I think, automotive industry wise, long-term trust is very important because once mass production started in automotive, it will continue very long time, 10 years, 15 years, 20 years for automotive normally. So, under current geopolitical situation, also, supply disruption in these several years, yeah, OEM and Tier 1 is really realized. Also, Tier 2, Renesas really realized supply chain with trust, long-term trust relationship is a very key thing. So I believe, I think Taiwan and Japan must be a best partner for this kind of, very long-term relationship. So let's work together, collaborate more for future success. So thank you very much. 谢谢.
Thank you, Mr. Kataoka, for sharing on Renesas' value proposition and automotive industry from the perspective of semiconductor. Thank you once again. Kindly return to your seats. All right, our next speaker, Subaru EyeSight Driver Assist Technology is the world's first active safety system that uses a camera lens image detection capability to prevent collision and assist braking. Let us welcome the GM of ADAS Development Department and the Chief of Subaru Lab, Mr. Eiji Shibata. Welcome.
Hello, everyone. I'm Eiji Shibata from SUBARU Japan. And this presentation, I will explain our activity of the improving road safety with AI-based stereo camera object detection. And this is technical presentation. I'm sorry. And please go ahead. I will start. And this is overview of our company. Our main business unit is automotive. We have many unique technology. Sorry. And we have many unique technologies such as symmetrical AWD and stereo camera called EyeSight. In this session, I will focus on what kind of technology the stereo camera consists of and how it will evolve with AI. This slide shows our philosophy. Our corporate social responsibility is to achieve zero fatal accidents. We are tackling this goal with the safety technologies we've been developing and our DNA as an aircraft manufacturer. And I believe the key to achieve zero fatal accidents is the sensor, stereo camera. We have been developing in-house stereo camera for over 30 years, very long history we have. From planning to circuit board prototyping and software coding and vehicle testing, almost everything. This in-house development is our strength. I show an example in the video. I'm showing the raw data that was actually recorded by eyesight, not created manually. This data create eyesight inside. You can see that the objects are detected by a very large amount of point cloud data. So, for example, our system can detect vehicles which cut into the lane very accurately. Here is the basic principle of our stereo camera technology. The stereo cameras have two cameras, right and left. They are in different places, so they capture different viewpoints. We call the difference disparity and convert into distance. So the algorithm calculates an object distance based on triangulation. It's a very simple structure. I will explain our object detection method. The strength of our method is that it can detect objects using only distance. We call this general object detection. And the disparity image at the upper left shows everything in 3D scene, disparity image. Our algorithm first finds the road surface, next right image. Then everything above it is an obstacle in the car's driving environment. That's seen as the disparity index at the lower left image. By applying grouping, we identify all the obstacles to the car. And thank you. So how will this algorithm evolve with AI? The image shows an example. You can see everything in 3D by depth information. But you only understand the size, shape, and the position, and you cannot understand what it is from depth information alone. AI will add more information. For example, the purple means the roads, pink means the sidewalks, and this feature will help better recognition. Now, I would like to talk about the general development trend in cars and AI. There are many objects that must be detected in the driving situation, such as other cars, lanes, and traffic lights. In addition, the semiconductors need to operate with very limited power consumption and should be low cost. Therefore, highly integrated and efficient multitask network structure is often used. And here is a diagram of our AI architecture. We have developed our own multitask network, where over 20 heads, such as object detection, road marking detection, depth estimation, and segmentation, share a single backbone. We call this SUBARU AstraNet. And let's watch the video of SUBARU AstraNet. The drivable area is green, road marking, stop lines, traffic lights, and cars are also recognized at the same time. From here, I will explain how AI and stereo cameras are a very good combination. The upper left image is an AI road segmentation image of a hill in San Francisco. Even if the road structure is very complex, the CNN structure can help classify each pixel based on its surrounding context. This is the strength of AI. Meanwhile, our stereo camera can also calculate disparities for each pixel. It means that the disparity image from stereo cameras and the AI segmentation can be matched pixel for pixel perfectly because they are from the same image source. On the other hand, a system that combines different sensors, such as a monocular camera and LiDAR, does not work. I'm sorry. Does not work like this because the fusion from different sensors is not so easy. This is the reason I believe the AI stereo camera is best. Of course, AI is not perfect. For example, AI learns from training data, so the performance is lower in unknown situations. This is an example. It's not difficult to detect a pedestrian in the urban road's background because it's a normal situation. However, if I put the same pedestrian in the highway background using CG, this, the detection score will be low. Light image has similar problem. There are fundamental problems with AI. So, what can we do? We use the stereo camera and AI to complement each other. These are CG images with a person lying on the road. Of course, there are rare situations, but the stereo camera can potentially detect everything, even for the first time. But stereo cameras does not recognize what it is. It could be an obstacle to stop at, or just a bump to climb over. AI can classify it. So by combining the stereo cameras and AI, we can realize more reliable and robust sensors. This is our way. From here, I would like to talk about another topic, the challenge for applying AI to autonomous driving. The typical AD/ADAS systems are designed to be used on highways. However, there are various challenges in applying the system to urban roads. What's the difference? The essence of the problem is here. The physical parameters for steering control are different between highway and urban roads. On highways, the target steering angle is directly decided by the curvature of white lines. but on urban roads. What should be the physical parameters that is highly corrected with the steering angle? AI is a powerful tool for such problems. Even if we cannot design clear rules, a data-driven approach can lead to probable answers statistically. We are developing a path detection AI model like the end-to-end approach. This model inputs multiple path images to CNN and connects them with LSTM unit. When we use these methods, data and annotation are really important. About data annotation, there are many different driving situations in the real world. When we drive the car, we understand something and decide our behavior. But if we cannot define it, we can't create the training data. For example, there are no clear lanes in the intersection. Which lines should be learned as the correct driving path? The driving path also varies depending on the drivers on snowy roads and roads without a center line, no center lines. Furthermore, the result of recognition changes each time depending on the environment, such as light condition. Regardless of the evolution of AI, such repeated data collection and annotations and tests are always the most important. This is the development cycle of AI. We are not just an AI developer, we are a car manufacturer. We build our own test cars with autonomous driving functions and drive every day. Data collection, data management, and model development, learning, and test drive. We control everything internally. This is our strength. Our team often say, the car is the best teacher for us. Even the most stubborn engineers who don't listen to their bosses, but they recognize the problem by themselves when they are driving the car. Test drives are also very important for AI engineers. Let's watch a video of our autonomous driving car. In the snow road situation, this car only has a front cell camera. No radar, no LiDAR, no map. Only cell camera can control autonomous driving in the urban road, the mountain road. And while testing the autonomous driving cars, we have also developed a very large database system. Left image shows recorded data that can be searched with the load time and weather in our database. We have to try a lot of learning, so we use this system to manage which data is used for learning and which data for evaluation. Right image shows the results of our AI. The system has results from all software divisions, so we can compare the difference between each software. We built both on-premise and cloud environment for the training job. This image shows the architecture of our infrastructure of data pipeline, build pipeline, and AI training. And we use NVIDIA A100 GPUs to train our AI with a huge amount of data. And we create the pipeline which automatically build containers and start and the end training jobs. We have huge amount of driving data in on-premise storage, and we upload annotated images to the cloud to train our AI. This slide shows our cloud environment. We choose training environment depending on AI workloads. In early stage of AI development, we have to recreate training data frequently to support new methods, new models, because input-output formats change frequently. Last year, we built the data pre-processing pipeline on the Google Cloud by using Cloud Data Flow service to easily try new AI models and new data formats. On the other hand, we use the on-premise environment for heavy load training using a large amount of driving data. The final topic is development with CG. The camera sensor and CG technology are a very good combination. There are mainly three advantages. First is we can create the data with perfect labels and ground truth, such as accurate object distance and velocities. This is very important for AI development for training. Second is we can duplicate the same scene data with slightly different parameters, such as 30 meter, 31 meter, 32 meter. It is very important for detailed analysis of the problem. The last is we can create the edge case data that is difficult to record in an actual vehicle. For example, the collision scene. First example is the CG data with perfect labels. We create this data and use for AI training. Next example is the duplicating of the data. When we find some issues during the actual drive, we create the digital twin for deep analysis. We don't know if the problem is due to the weather or shape of the car or distance. However, we can change any parameters with CG. Let's watch a video. The first is original image from cell camera. In the next step, we create the digital twin like this, and we change some parameters. This is a moving wall. This is very good target for testing because the surface is very flat, and to calculate the accurate distance. Finally, I will explain that the development of creating pipeline. We are developing the pipeline that efficiently creates the CG using the recognition results from our cell cameras. Based on the detection results from eyesight, we create the 3D point cloud space with labels. We compare the detection results with the map data and place the assets in proper positions in CG space. And next, this video, CG creating pipeline. The first is detection results of eyesight, and this shows 3D point cloud from eyesight to depth data. The labeling data is also created by eyesight AI detection result. And the last is the digital twin data. And here is the conclusion. We developed SUBARU AstraNet AI with a very good combination of our stereo camera. Regardless of the evolution of AI, repeated data collection, repeated annotations, and test driving are always the most important. We build automation pipelines for AI training in both on-premise and cloud to achieve more efficient development. And we utilize the digital twin generated from stereo camera data to develop eyesight and our AI. That's all my presentation. Thank you for attention.
Thank you, Mr. Shibata, for your wonderful presentation of the Subaru Lab development with the AI. Thank you. Kindly return to the seats with care. All right, shall we give another round of applause to our amazing speakers from today? Thank you all for joining us. And this marks the end of Asia Smart Mobility Ecosystem Forum. Thank you all once again for the support and participation. We'll see you later in the afternoon. Thank you all for joining.